Hello, this is Today Tech and welcome to the basics of subnetting. Today we are going to walk you through subnetting and help you understand this topic. Before we dig deep to this topic, let's clarify some things. A host, also known as a network host, is a computer or other device that communicates with other hosts on a network. Hosts on a network includes clients and servers that send or receive data, services, or applications. Now, a host is connected to the internet via a communication link. The boundary between the link and the host is called an interface. Typically, a host has only one interface. On the other hand, a communication device such as a router has two or more links and thus two or more interfaces. Both the host and the router send and receive IP datagrams via these interfaces, which is possible if only the interface have their addresses. These addresses are called IP address, an identifying number that is associated with a specific computer or computer network that allows the devices connected to the internet send and receive information. Internet Protocol version 4 routes today's internet traffic. IP version 4 addresses are 32-bit integers that can be expressed in hexadecimal notation. The more common format, known as dotted quad or dotted decimal, is x.x.x.x, where each x can be any value between 0 and 255. For example, 192.0.2.146 is a valid IPv4 address. Additionally, there are 4.3 billion possible addresses in IPv4, and yes, we've run out. If you think about it, how many devices were connected to our households? In our household, we were very blessed that we were connected to our neighbor's internet connection. I have my phone, I have my computer, there's my brother's phone and my mother's phone and my brother's laptop. And yes, there's still other people connecting from the other household to our neighbor's internet connection. Do you know the median American household has 5 devices, including smartphones, computers, laptops, tablets, and streaming media devices? That doesn't even include the range of devices that fall under the Internet of Things or the IoT category, such as connected thermostats, smart speakers, and doorbell cameras. So, in today's world of ultra-connected computer networks, where every stationary and mobile device now has an IP address, it turns out that 4.3 billion of them isn't nearly enough. To allocate IP addresses, we do subnetting. Probably now you're wondering, what is subnetting? Subnetting provides the flexibility of borrowing bits of host part of the IP address and using them in a network, basically called subnets. By using subnetting, one single IP address can be used to have smaller subnetworks, which provide better network management capabilities and helps relieve network congestion. Subnet mask separates the IP address into network and host addresses. A subnet mask is a number that defines a range of IP addresses available within a network. A single subnet mask limits the number of valid IPs for a specific network. A host ID is a specific piece of information which uniquely identifies a device. A network ID is the portion of an IP address that identifies the IP network on which a host resides. Lastly, a broadcast ID is a portion of an IP address that identifies the broadcast address. To fully understand what subnetting is, let's look at the following scenarios. Everyone, welcome to our subnetting scenario 1. So we have our problem here. Suppose I have a network ID which is 192.168.178.0/25 and have to subdivide it into 4 households. So we are dealing with 4 households here, keep it in mind. How can I subdivide the network? We have to find the network ID, the new subnet mask, the number of usable hosts, and the broadcast ID. So let's keep in mind that we're dealing with a class C network. So for class C network, we can only manipulate the 4th octet of this network, which is 0. So when we are dealing with class C network, you will see what are the network IDs we can create and the broadcast IDs that we will create. Now we have to move on. We have to create a table because this is a lot easier than just dealing with binaries. Now we will create a table which includes the subnet, the host, and the subnet mask. So the subnet, basically, it is the number of target subnets that we are looking for. For the second column, we have the number of available hosts, and the subnet mask is basically the number that defines the IP addresses available for the network. Now, how can we complete the first column? Now, to identify the first column, we will just have to double the number presiding to get the next number. So we have 1. Of course, you have to start with 1 because how can you subdivide something from 0, right? So 1 multiplied by 2 is equals to 2, of course. And 2 multiplied by 2 is equals to 4. From 4 multiplied by 2 is equals to 8. So basically, you know the drill until you get here in 256. So we can extend it a little further, but we will stop here because we already got our target of subnetting, which is 4, because we are dealing here with 4 households. So now to get the second column, we just basically place the reverse of the first column here. So if we ended up with 256, we'll start at 256 here in the second column. So 256, 128, 64, 32, so on and so forth. Just in case you find it hard to reverse, basically just put 256 here, which is the largest number here in the first column, and then divide it by 2. So 256 divided by 2 is 128, and then 128 divided by 264, so on and so forth until you get here in 1. Now, to get the subnet mask, we will start at /24, and then we will just add 1 to it, which is /25 plus 1, we get /26, so on and so forth until you get here in /32. What is our end product now? So our end product now is that we have our subdivision at our target subnet, which is 4. We just basically encircle it in red. And the number of available hosts for the subnet of 4 is 64. And the new subnet mask that we will use now is /26. So from this, we can create another table to answer the problem, to answer the questions rather we presented to satisfy our problem. Now, here you can see 4 columns containing the network ID, the subnet mask, the number of usable hosts, and the broadcast ID. So basically, we just place it here in top because we are looking for it. And we will use the end products of our first table to actually complete this table. So now, let's also keep in mind that our original network ID is 192.168.178.0, and we will subdivide it into 4 households. And then the network IDs and the corresponding broadcast IDs will also be 4. That's why we have 4 columns here. And then the number of usable hosts, which we will use our number of available hosts from, and then the new subnet mask, which is /26, that's why it's already here. So to get the first network ID, of course, we have to place 192.168.178.0 because it is still part of our subdivision and it is our basis for subnetting. To get the next network ID, we just have to keep in mind again that we are dealing here with class C. So for class C, we can only manipulate the 4th octet. So here in this network ID, which is the 4th octet, it is the 0 here. So again, this first network ID is just basically the original network ID. And then from here, we will just add 64 because 64 here is the number of available hosts. So we're just going to add 64 to 0. So 64 plus 0 is equals to 192.168.178.64. Again, for class C, we can only manipulate the fourth octet, and basically the first three octets, which is 192.168.178, will stay the same. So from 192.168.178, we already got our second network ID, which is 192.168.178.64. Now, to get the third one, let's add 64 to 64. So 64 plus 64 is equals to 128. And to get the last one, we just basically add 128 plus 64, which is 192. Again, to get the network ID, we can use this formula I created. Next network ID is equals to presiding plus 64, and the answer must be on fourth octet because again, we're dealing here with class C subnetting. Now, we already have our subnet mask, which is /26. That's why it's already here. So basically, every single subnetworks have the same subnet mask. Now, our number for available hosts was 64. We already emphasized it enough. But we were looking for the number of usable hosts. Keep in mind that the first host is reserved for network ID and the last one is reserved for the broadcast ID. Basically, because it's already reserved, it is already of use. So now how can we get the number of usable hosts here? We just have to use another formula I created, which is basically number is equals to available hosts minus 2. So 64 minus 2 is equals to 62. And basically, all of these networks have the same usable hosts. Now, we are now dealing with our fourth column here. Basically, because we already have our number of available hosts here. And we already know that the first one is reserved for the network ID. Hence, our broadcast ID here for the last. Basically, we will just have to use this formula again, which is broadcast ID is equals to next network ID minus 1. So, what is the next network ID we are referring to here? Remember, we have our second network ID, which is 192.168.178.64. Because we are dealing here with broadcast ID, we just have to minus the fourth octet here with 1. So again, we got this formula from here because we already have our network ID, and what we're looking for here is the broadcast ID. So basically, we just have to minus it from 1. Why are we not minusing, or why we're not subtracting for the original network ID? Basically, you cannot put negative 1 as your network ID. We're only dealing here with positive integers. So, from 192.168.178.64, we will just have to minus 1 from 64. Hence, we have 192.168.178.63. So that's what we're going to do here to get the succeeding ones. So from 192.168.178.128, we can get 192.168.178.127, because we just basically have to minus 1 from 128. To get the third one, 192.168.178.192. Basically, we just have to minus 1 from 192, so we can get 192.168.178.191. Now, we're dealing here with the fourth broadcast ID. How can we get the fourth broadcast ID? So basically, we will just add 64 or the number of available hosts here from the network ID, which is located at the fourth octet, and then we will just have to minus 1 from it. Basically, we will use these two formulas at once. So 192.168.178.192, so the network ID is 192. If we will add 64 on it, we will get 256. So 256 is the next network ID. So basically, we'll just have to minus 1 from it, and then we will get 192.168.178.255. Then you have all the questions that will satisfy our problem for scenario 1. Hello everyone, so we are now done with scenario 1 and we are now dealing with subnetting scenario 2. And for this time, we are going to discuss about the subnetting table for class B. So we have another scenario. Suppose I have a network ID which is 172.16.0.0/16 and I have to subdivide it into 4 new subnets. How can I subdivide the network? Find the network ID, new subnet mask, number of usable hosts, and broadcast ID. Basically, it's just the same scenario. The main difference is that we are dealing with another class. So right now we have another table. As you can see, the numbers are getting huge, but don't be afraid. This was just still the same, and it's still a simple math. If you have listened to my discussion earlier, probably you know about the subnet column, the host column, and the subnet mask. If you already forgot it, it's just the subnet mask is the number of the subnets or the target subnets in the problem. We have our host, which is basically the number of available hosts. Keep in mind, this is the number of available hosts. And the subnet mask is the no subnet mask for the target subnets. Now, you see, again, it's the same column. It's just that it has bigger numbers. You have to increment 1 by multiplying it with 2. So 1 times 3 is equals to 2. 2 times 3 is equals to 4. 4 times 4 is equals to 8. And, you know, I mean, 4 times 2 is equals to 8. I'm sorry. 8 times 2 is equals to 16. 16 times 6 is 32, and so on and so forth until we reach here. Now, for our host, basically, we have to reverse the first column and just place it here, or put the last one, place it here in 1, subnet of 1, and then we will divide it by 2. So if you find it harder to divide it every time, you just basically copy the reverse of the first column. So we have the 65,536 here until we get to 1. In the subnet of 65,536, we have 1 host. And now for the subnet mask, because we are dealing here with 16, of course, we have to start a subnet of /16, subnet mask of /16, until we reach the end where the subnet is 65,536 and the host that corresponds to it is 1. So basically, this table for class B is just the same for class C. The main difference is that we're dealing here with class B, and we can see that difference in the other table. Now, let's keep in mind the 3 bases for our answers. I forgot to actually encircle it so that you will remember. So this is what we're dealing with. This is our end product. We have the subnet of 4. We're looking for subnets of 4 where the host is 16,384 and the subnet mask is /18. If you haven't seen my disclaimer already, yes, I did not script this part because I just wanted to teach you the most truthful way I can be. Now, we are to subdivide again 4 subnets with 16,384 available hosts, and /18 is our new subnet mask. The regional network ID is 172.16.0.0. We have to divide the number of usable hosts with 256. Now, as you can see, the 16,384 is a big number, and since we're dealing here with octets, the end number for an octet is 256. So after 256, the thing has to start again. Here in our problem here, we are dealing with 16,384. We just need simple math to add things or to increment things in our network ID. So 16,384, if you will divide it, so we have our calculator in case you don't trust me. So 16,384, basically you just divide it with 256 and the answer is 64. So 64 will be added now in the third octet to actually get the next network ID. Again, just like the other one, the original network ID will be placed here. I'm sorry, I have to do another color. Okay, 172.16.0.0 is our original network ID, and for us to get the next one, we just have to add 64, so we can get 172.16.64.0. Basically, it's just the same. The main difference that we will add 64 in the third octet. So what is the third octet in our network ID presented here? It's this part. Okay, if you're still looking, 172 is the first, 16 is the second, and the 0 here before the other 0 is the third octet. So again, we'll just add 64 in the third octet. We got 64 from dividing 16,384 with 256. Now to get the other one, of course, we're gonna do another simple math. 172.16.128.0 is our next network ID, and the last one will be 172.16.192.0. Again, these are all the same. You already saw the pattern with the other table in the other scenario. It's just basically the same. So subnet mask, we already got our new subnet mask, which is /18. So it's just one and the same. And now we have our number of usable hosts. Of course, number is equals to available hosts minus 2. So we have 16,382, and all of them were the same. Now for our broadcast ID, this is the main difference though, is that as you can see with our last scenario, we actually put the broadcast ID here in the last octet. When we're dealing with class B, again, I need to emphasize this so that you will know what's going on, is that if we're dealing with class B IDs, we can only manipulate the third octet. So the third octet is what we can manipulate from here. So we'll just basically get this 64, which is our next network ID, minus 1, and just place it here. So again, it's just very simple math. 64 minus 1 is just basically 63. Okay, 128 is basically minus 1 is just 127. 192 minus 1 is 191. I'm very sorry, I'm filming this at 2 a.m. Now, to get the fourth network ID, what we need to do is just basically 192 plus 64 And just in case you don't trust me again, 192 plus 64 is equals to 256. And now if we will minus 1 from it, we will get 255 here. Well, if you will observe, there were two main differences between the two classes. Class BADs has 16 bits to play with versus the Class C, which has 8 bits, meaning Class BADs can be manipulated starting on the 3rd octet versus the Class C, which can be manipulated from the 4th octet. I hope that this introduction to subnetting helped you in some ways to boost your knowledge about this topic. This is Today Tech, and this has been the basics of subnetting.